Okay class, here we go again with some more stoichiometry problems. Our objective for today is that you can work mass-to-atom problems. So here we go. If you remember, in order to get from moles to atoms, we are going to have to use Avogadro's number. To tie this into our building illustration, in order to go from the mole level of the building to the atom level of the building, we are going to use the relationship 6.022 times 10 to the 23rd atoms over 1 mole. If we're going from atoms to moles, then we're going to have to use the opposite. In other words, the relationship 1 mole over 6.022 times 10 to the 23rd atoms. Okay, so let's apply this into a problem. How many atoms of water is formed from 65 grams of oxygen in the synthesis of water? After writing out a balanced equation, we get to label our buildings. The one on the left is going to be labeled oxygen, while the one on the right is going to be labeled water. We are given 65 grams of oxygen, so we are going to put that in the mass portion of our oxygen building. We want to get atoms of water, so we're going to put a question mark on our atoms floor of the water building. Now we have a starting and ending point, which we can plan out a pathway to find our solution. We're going to go from mass of O2 to moles of O2, or from mass of oxygen to moles of oxygen. From there, we're going to use the mole ratio to get to moles of water. And then finally, we're going to use Avogadro's number to convert moles of water to atoms of water. Now let's solve this problem. We're going to put what is given over 1, so 65 grams of O2 over 1. Then we're going to multiply it by 1 mole of O2 over 32 grams of O2. Remember, oxygen is diatomic, so its atomic mass is doubled. This gives us 2.03 moles of oxygen. Now we're going to take our moles of oxygen to moles of water using the mole ratio of 2 moles of water over 1 mole of oxygen. Once we do this, it's going to give us 4.06 moles of water. Now our last step is to take our moles of water and convert it to atoms using the relationship of 6.022 times 10 to the 23rd atoms of water over 1 mole of water. This gives me 2.45 times 10 to the 24th power of atoms of water molecules formed, and this is our correct answer. Okay, hey, let's start another one. Let's say magnesium bromide reacts with potassium oxide to form potassium bromide and magnesium oxide. If we have 143.7 grams of magnesium bromide, then how many atoms of potassium bromide can be formed? Our first step is going to be balance the equation, and we get MgBr2 plus K2O yields 2 KBr plus MgO. Now we label our buildings, with the left one being magnesium bromide and the right one being potassium bromide. So now that we have that, we are given that we have 143.7 grams of magnesium bromide. So let's put that in the mass portion of my magnesium bromide building. We are wanting to find atoms of potassium bromide, so we're going to have to put a question mark on the atoms floor of the potassium bromide building. Now we have a starting and ending point, so let's start working the math portion. In order to go from grams of magnesium bromide to moles of magnesium bromide, we are going to have to multiply our 143.7 grams of magnesium bromide over 1 by 1 mole of magnesium bromide over its formula mass, which is 184 grams of magnesium bromide. This gives us 0.78 moles of magnesium bromide. Now that we have moles of magnesium bromide, we can use the mole ratio of 2 moles of potassium bromide over 1 mole of magnesium bromide. Once we do this and multiply it out, we get 1.5 moles of potassium bromide formed. In order to get this 1.5 moles of potassium bromide to atoms, we finally have to use Avogadro's number, or the relationship of 6.022 times 10 to the 23rd atoms of potassium bromide over 1 mole of potassium bromide. This gives me an answer of 9.41 times 10 to the 23rd atoms of potassium bromide formed. Okay, here's our third and final one. How many atoms of calcium bromide do I form from a reaction between calcium nitride and 204.8 grams of potassium bromide? Our unbalanced equation would read Ca3N2 plus KBr yields K3N plus CaBr2. Once we balance this equation out, we get Ca3N2 plus 6KBr yields 2K3N plus 3CaBr2. Now that we can start off labeling our buildings. Our building on the left is going to be KBr, while our building on the right is going to be calcium bromide. So potassium bromide on the left, calcium bromide on the right. We are given 204.8 grams of potassium bromide. So that is going to be on the mass floor of the potassium bromide building. And we're looking for atoms of calcium bromide, so that's going to be a question mark on the atoms floor of the calcium bromide building. Now that we have a starting and ending point, we can start working our problems. Our first step is getting our grams of potassium bromide to moles of potassium bromide. We do this by simply multiplying 204.8 grams of potassium bromide, in other words, what is given, over 1, by 1 mole of potassium bromide over the formula mass of potassium bromide, or 120 grams of potassium bromide. This gives us 1.71 moles of potassium bromide. Now, we can take our moles of potassium bromide and multiply it by the mole ratio. In other words, we can take 1.71 moles of potassium bromide and multiply it by 3 moles of calcium bromide over 6 moles of potassium bromide. Once we multiply and divide out, we get 0.85 moles of calcium bromide formed. My last step is multiplying my moles of calcium bromide by 6.022 times 10 to the 23rd atoms of calcium bromide over 1 mole of calcium bromide. This gives me 5.14 times 10 to the 23rd atoms of calcium bromide. Okay, I feel that that is enough for you to go through right now, so keep up the good work in the classroom. Make sure you take these one step at a time, and when in doubt, make sure you use your building illustration. And saying all of that, see you next time.